Hello, I'm Mark and welcome to my channel. In today's video, I'm going to showcase my data-driven night and day simulation system that I'll be featuring in my next How to Build video series. So as you can see right now, we've got a system that is currently using my time simulation component, and the time simulation component is driving the day-night simulation here. So we're now in the daytime as time is moving very quickly. We're currently using Open World 1, which is a world in which we only have 1 hour of day and 1 hour of night. So it's 2 hours per rotation. And as you can see, the sun is moving, it's going down. We're now into the evening. And as we the time keeps moving forward, and it's going pretty quick right now, set it up to move pretty speedily. We're now coming into midnight and the lights. So this simulation system will control the material. It will also control all of the light sources and orbits of any light sources in there. So we actually have two. We have starlight and we actually have the sun, and there it is going up into the orbit. I'll just switch back to where we can catch it going into the west and into sunset, and it'll also update any luminescence needed. So as you can see, it's pretty intense during the midday, but then as we start moving into the afternoon, it'll take some of the intensity out of the light, and so this system will manage all of those. And as you can see, it's now a lot darker, and suddenly the gloom is kind of like got a little bit brighter as we adjust the luminescence there too for the nighttime off the starlight. All right, so I'm just going to stop this right here. So again, like I said, everything is being driven by my time simulation component, which was created in the previous video series. And so we're just using the core chronometer, using the default time within the core chronometer, and then I'm just gonna, all I've done is here, I've just sped everything up to about 120 to make sure things really rocket through. And I will leave a link to that series in the description below, since it is going to be a prerequisite for when we actually build this out in the next how-to series. But again, nothing's really changed too much. The data table's the same, and the setup here is the same. All I've done is just add, I think, 3 functions, because we just need to get some data that this system is calculating for us, and then that we can then pass along to our SkySphere up here, which will then translate that into sun position for us, and manage all of the day, night, and light intensity stuff. So like I said, I'll leave a link to this in the description below. And as you can see, this system is actually going to be using hours in day, which you currently saw. So World 1 is set up for 2 hours in a day. So 1 hour of daylight, 1 hour of night light, and that's how I've kind of set things up on the curve. So it's 12 hours a day, 12 hours a night, and that's kind of set up there. And then I'm not doing anything with the week, but the system will look at the days in the year too. So if we were to come over to the sky config, right, everything is done by, so each record is considered, can be linked to a map, or you could use one record for all your maps, or you could have different setups for different maps. Again, highly configurable for the system. But then under each record, we actually have time periods, and these time periods relate to the days in the year. So if you just want one time period, then we'll take one time period will be 12 days in the year. For this map, it would be 365 if I was using this clock. But if I wanted to break it up into seasons, and I wanted to have different, a different sun track in the sky. So if I wanted to have in the wintertime, I wanted to have the sun lower in the sky as it's coming over, and I wanted to have more dark and less light, you could do, you change that in the curve, and we would just update the season. And again, you could also do that in the summer, where you'd have a lot more sunlight than you would darkness. So you can create those interesting setups, and that's all can be done through the vector curve system within the table. And so that comes over here. So everything's set up by time periods. So if you want one time period, you can do that. If you want two for summer and winter, you could do that. But then if you wanted to have spring, summer, autumn, and autumn and winter, you could break it up, and the system will calculate that again from data coming from these time simulation components. And then within each time period, we've got our light orbits, and then we've got our sky configuration. And so our light orbits, so I'm just going to come over here and make sure that, so in this map, I've just got two lights. I've got the sun, and then I've got the stars. And then when I come into an instance version of my SkySphere here, right, all I'm doing is I'm just going to map the sun to the sun and the stars to the stars. And this key needs to map to this. And then this is the primary light source. So this is the light source that's going to be driving the materials in the sky. So we identify which one of these is the primary there, and then what we do is we can then use the same key in the data table to figure out how we want to move that light through the sky. And as you can see here, I've got the sun and I've got the stars. They're both using vector curves. So this is using a equatorial solstice curve that I created. And then also within that, we can control the luminescence. So as you can see here, I've got midday, morning, and evening. And then based on the pitch in the yaw of the position of this sun of this light in the sky, we can then set the luminescence, and then I can also set the interpolation speed if I want it to be quicker or slower. So we've got some tuning there, and we can also set the intensity. So during the midday, I've got intensity of 6, where we take some of the intensity out when we get to in the morning and in the evening. And then under stars, that's pretty much going to be consistent on a downward track, 90 degrees, but again, I'm able to control the amount of lux. So there's night AM, and then there's night PM here, and again, based on the pitch and the yaw angle, we can go ahead and decide what we want to do there. So there's 0.3, same interpolation speed. And then what I do in the daytime, I just set the intensity to 0. That way, the starlight isn't competing with the sun. It shouldn't compete. You wouldn't see it too much because based on the intensity of the light. But if there's any little shadow, you can kind of turn that off before to your liking. So that's what that's there for. And then finally, here's the sky configuration. So this is the material switches that we're doing, and because we're starting at midnight, and then we're changing it during the day, I actually had to split the nighttime into 2. But that's okay, because you may want to have a different sky material for morning night versus evening night. But you could also add additional materials in here for dawn and dusk as well as day. And all of that, and again, it's all controlled through the pitch and the yaw and this is all based on the primary light source that's going through the sky. And then you can also decide which material you want to switch. So if you only have one material, you just can change the material at element 0. But if you had multiple, you could also do that as well. So again, some flexibility in the system that's built into the system. And that I think is it. So, and again, it's it's highly customizable through the table system. It's designed to be that way. And then also I can switch over. So again, so we saw what it looked like at local time. So I'm going to switch it over to UTC. So with very little effort, the system will auto calculate. So UTC is running a 24-hour clock, so it's running a lot. So the sun position is moving a lot slower, and as you can see, the character, we also started in daytime at roughly the 8 o'clock position, and that's 8 a.m. in the morning. And so now we're moving through to coming up to 9 and we're continuing to move. Okie dokie. And as you can see up in the right hand corner, just ignore the nanite error message, but you can see there's right now I've got two little numbers moving. The one in green is the position of the sun's pitch, and then the one in orange is the yaw angle of the sun as it's going through the sky. So you can see it's kind of up there and it's continuing to move. All right, so I'm just going to put that away. All right, so as far as the series that I'm going to be building in the next, my next series, I'm going to be breaking it into probably about 2 to 3 parts. The first part will just go ahead and it will be some minor changes to the time simulation component. No real changes to the logic again. It's just really outputting functions. And then in that series, we'll also go ahead and build out this table structure, which we'll be using to drive the day-night simulation. And then in part 2, we'll go ahead and build out the sky sphere, set it all up. So with all the calculations it needs to make to do all the plot tracks and everything. And then in part 3, we'll go ahead and set up the map and set all the data up and get our first simulation going based on the simulation code. So that's going to do it for my little showcase. If you like what I'm doing, feel free to like and share my videos, as well as subscribe to my channel, and I will see you in my next video. Cheers. Bye.